Hey college! Today, our first focus will be to notate and construct inharmonically equivalent intervals. Sounds like fun, right? Well, trust me, this process is not as intimidating as the music you just heard may suggest. In actuality, the very thought of constructing inharmonically equivalent intervals makes me so happy that I feel like dancing. So, let's begin. Inharmonic intervals. These intervals will sound the same, although they look different due to the quality difference on paper. This is where you keep one note the same and alter the other one. In the first example right here, you should note that the natural sign applies to the first C and the sharp sign applies to the second C. They both have the same generic number of 1, and there's one chromatic semitone difference. So C to C sharp is an A1. In the next example, we have the generic number of a 2, and we have a C to a D flat. A C to a D flat is a minor second. They will sound the same, but they look different on paper, just like when we studied inharmonic equivalence. Now, down here, what we need to do is identify the name and quality of the given interval. Then we'll write inharmonic intervals next to the given intervals below. They must sound the same but have a different quality. So take a moment to do this now, keeping in mind that we want to alter only one note. Keep one note the same and alter the other. So let's try the first example together. I'm in treble clef. I have a C and a D. That's identified as a major second. Decide now which note you want to keep the same and which one you want to make the inharmonic equivalent of. I'll keep C the same. That means D is the inharmonic equivalent to what? Well, the first thing that comes to mind is an E double flat. Now, name the specific interval from C to E double flat, and you'll realize that is a diminished third. If I wanted to, I could keep the D the same and alter the C. What's another way of sounding a C? A B sharp. A B sharp to a D is still going to be a diminished third. So notice I've only changed one note. That's what you'll need to do in these following examples. Remember that the interval must be inharmonically equivalent, so that if I were to go play it on the piano, they would sound the same. Good luck, college. Okay, college, so hopefully you had a chance to finish most of these, if not all. What we wanted to do was to identify the name and quality of the given interval, then rewrite the interval as an inharmonic equivalent so that it will sound the same as the given one. And the idea here was to change just one note only, and we probably have similar answers or different answers depending on which note you decided to alter. So if I take a look at the second line here, the second to last measure, I'll circle it here. I'll just pick this one as an example. So we started out with a diminished eighth. I've rewritten it as a major seventh. That will sound the same. I changed the top note G flat to its inharmonically equivalent note, which is F sharp, and kept G the same, therefore making it a major seventh. Perhaps some of you decided to put the E double sharp like this and kept the G. Okay, if you did that, that would still sound the same, but we would have to call that a doubly augmented sixth. You should also know that when taking exams or quizzes or doing homework assignments, you have to really read the directions carefully and as to whether or not they want you to alter one note or alter both notes. Now in these examples we've altered only one note, but we can take one of these examples and practice altering both notes so they sound inharmonically equivalent to the given interval. So let me pick a random measure. How about this one that I'm circling? Okay. So our original interval is an augmented sixth. We have a C up to an A sharp. That's an A6. I have rewritten it inharmonically as a minor seventh, which is C to a B flat. So I've changed the top note, but I can also change the bottom note. So how about I decide to do a B sharp, which is the inharmonically equivalent to that of a C, and how about I keep the B flat right up here? You'll realize that if we changed both notes, that now the green interval I just wrote is now going to be called a doubly diminished eighth. Okay, so at the bottom here are examples of inharmonic intervals based on C, and you could take a moment to read that while we get ready to now talk about our next topic, which is the rule of 9. Now it's on to interval inversion and the rule of 9. In music, you should know that the verb invert means to move the lowest note in a group one octave higher. In our first example, we will use the interval of D to A, which is a perfect fifth. In order to invert this interval, we must move the lowest note, the D, one octave higher. When we do so, the result is A to D, which is a perfect fourth. Perfects will always invert to perfects, and fourths will always invert to fifths. In our next example, we will use C to E, which is a major third. When we take the lowest note, that is the C, and we move it one octave higher, the result is a sixth. The quality is minor. The notes are 8 half steps apart, and it's a minor sixth because C natural is not in the key of E. Key point. Majors and minors will always invert to each other, as will thirds and sixths. So for example, a minor third will always invert to a major sixth. The rule of 9 comes into play when we have 5 plus 4 in the first example, and 3 plus 6 in the second example. Notice that when you add up the first interval quality with its inversion, the result in all cases equals 9. 4 plus 5, 3 plus 6. Do you know the answer to this? A major second plus a what will equal a ninth. Hopefully you said minor seventh, because remember, when we're dealing with interval inversion, majors invert to minor, minors invert to major, and perfects invert to perfect, and they equal 9. Why does it add up to 9? Well, many students are initially confused by this fact that inverting intervals adds up to 9. An octave, we know, has 8 notes, and there is an octave between the bottom note of the first and the top note of the inverted interval. In this example, we have a C to a G, which the generic name is a fifth. We can count up 1, 2, 3, 4, 5. When inverted and the C is on top, we have 1, 2, 3, 4, a fourth. In other words, the answer is that the note in the middle, which is the G, is counted twice. Remember, we count both notes when calculating an interval, so the G has effectively been counted twice. So now let's look at some more interval inversions. Now let's invert the G to an A, which is a major second. If we take the lowest note, G, and move it an octave higher, the result is now an A up to a G, which is a minor seventh. So now we've figured out that seconds and sevenths will always invert to each other. And there's our rule of 9. 2 plus 7 equals 9. Since seconds and sevenths are major and minor, that means if we have a major second, it will invert to a minor seventh. If we have a minor second, it will invert to a major seventh. The final rule of interval inversion states that in an augmented and diminished intervals always invert to each other. For example, C to F sharp is an A4. It also results in an F sharp to a C when inverted, which is a diminished fifth. Here it is visually. In our first example here, we have an A4, C up to F sharp. If we take the C and move it up one octave, our interval is now a D5. In this next measure over here, we start out with a D5, a C up to a G flat, move the C one octave higher, and now the interval is a G flat to a C, resulting in an A4. Notice I'm capitalizing my A's, and I'm putting my D's in lowercase for diminished. By the way, what is another name for these intervals that you see? Hopefully, you realize that they are tritones. The A4 and the D5 are considered tritones. Okay, what we need to do now is connect lines from the interval column to its interval inversion. So the left-hand column is the interval, and we have seconds, thirds, fourths, fifths, sixths, and sevenths. And then we need to connect that line to what it's going to become after it's inverted. So take a moment to do that now on your paper. And hopefully your lines look similar to mine, because remember, when we're dealing with inversions, we're dealing with the rule of 9. So we want them to add up to 9. Here's a chart which sort of explains things really nicely for us. If the interval quality is major, after inversion it will become minor. If the interval is minor, after inverted it will become major. If the interval is augmented, after inversion will become diminished. If the interval is diminished, after inversion it will become augmented. If the interval is perfect, after inversion it will stay perfect. And these will add up to the generic number of 9. Let's take a look at interval inversion from the piano point of view. So let's start out on a C right here and go up a perfect fifth. That would be to a G. Listen to the perfect fifth again, C to G. I can take that lowest note, the C, and move it up one octave, so now G is my lowest note, resulting in a perfect fourth. 5 plus 4 equals 9, and that's the rule of 9. Let's start out with a major third. I'll do C to E. C to E is a major third. We know that majors invert to minors. We could take 9 and subtract 3, so we know that it's going to be a sixth, and it must be a minor sixth. E up to C. Let's start out with a fourth and go C to F. That's a fourth and it's perfect. Let's invert it. Now it's a perfect fifth. Let's start out with a minor third. C to E flat. If E flat becomes my lowest note because I invert it, and C is my top note, that means a minor third inverts to a major sixth. Minor third, major sixth. The same idea applies to tritones, which we know are A4s and D5s. So here I can do a tritone, an augmented fourth from a C to an F sharp. When inverted, becomes a D5. A4, D5. And there's the tritone. So when you are given an interval and the directions ask you to name the specific interval, but you're struggling with it, consider inverting the interval and finding the specific quality and generic number of the inverted interval, which will help you determine the original interval. So here are examples of interval inversions, and what I'd like you to do is spend just very brief time figuring out the specific name for all of these intervals. Try that now. So you should be done with the blue and the red. Let's see how you did. Major second inverts to a minor seventh. Minor second inverts to a major seventh. Next, try the light green and yellow. And for the light green, G to A sharp is an augmented second. A sharp up to G is a diminished seventh. Remember that augmented and diminished intervals invert to one another. And don't forget about the rule of 9. Let's check out how you did with yellow. D to F sharp, major third. F sharp to D, minor sixth. Try the next set. Let's check out purple, F to A flat, minor third, A flat up to F, major sixth. Orange, D sharp to F, diminished third, F to D sharp, augmented sixth. And let's try the last set at the bottom. And looking at our dark green, we have an F up to a B flat, perfect fourth, and a B flat up to an F is a P5. And the last example, A flat to a D, there's our tritone, it's written as an augmented fourth, and then a D up to an A flat is written as a diminished fifth. How'd you do? Let's move on. What we need to do here is study the notated interval and mentally calculate its type and quality. In other words, try not writing anything down. Then, underneath each measure is a list of intervals. Find the interval representing the inversion of the notated interval. So if we did the first one together, we'll call that the red star example. I can't write anything down, but I'm looking at an F sharp to a C. In my mind, I figured out that that interval is a diminished fifth, but that's not the answer. The answer is the inversion of the interval that is shown. What does a D5 invert to? A D5 inverts to an A4, and that's my answer. I'd like you to spend some time mentally studying these other intervals and coming up with the interval that represents the inversion of the one that's written. Good luck, college. Okay, college, I'm going to reveal each answer, and you could check your work and see how you did. So here's the second measure. Major sixth. The interval that is shown is inverted as a major sixth. Picture the F going on top. What's the interval of an A flat up to an F? That's a major sixth. The next one, we're taking the E flat, moving it up the octave, so that means a D to an E flat is a minor second. Let's head over to the yellow star. Let's take the B, move it up an octave, so from C up to B would be a major seventh. The next one, we have a D to a G flat. If we invert that, it becomes an augmented fifth. The next one, A flat up to F sharp, inverted, is a D3. Let's head down. For the purple star, D to F sharp, and notice now we're in bass clef. D to F sharp, so F sharp to D, minor sixth. Next one, orange star, F sharp to D, inverted, D to F sharp, would be a major third. The next one, G to A flat, minor second, A flat up to G, major seventh. And for the last one, D to C sharp, take the D, move it up an octave, C sharp to D is a minor second. So let's just summarize interval inversion. To find the inversion of an interval, what you do is to name the new interval, subtract the name of the old interval from 9. The inversion of a perfect interval is still perfect. The inversion of a major interval is minor, and of a minor interval is major. The inversion of an augmented interval is diminished, and of a diminished interval is augmented. Can you quickly identify the inversions of the following intervals? A diminished sixth inverts to an augmented third. A perfect fifth inverts to a perfect fourth. An augmented fourth inverts to a diminished fifth. A minor second will invert to a major seventh. And a minor sixth will invert to a major third. College, here's one last activity to do. Today, each measure contains two harmonic intervals that are inverted. Name every specific interval. And I'll give you just a few minutes to work on this before I reveal the answers. Good luck. Okay, college, let's see how you did. I'm going to reveal each measure one at a time, and you can check your work. This concludes today's video, college. Thanks so much for watching, and make it a great day.